To do these definite integration questions, you need to know some of the integration rules, such as integral of sine x dx is negative cosine x plus c, and integral of cosine x dx is positive sine of x plus c. And therefore, this will be integral of 0 to pi 5 sine t dt plus 0 to pi 8 cosine t dt. You can split the integrals like this, and these numbers can be in front. So you integrate and the integral of sine is cosine t, actually negative cosine t, and integral of cosine is positive sine. I should be putting dt there. So these are the antiderivatives, and then the difference between an indefinite integral with a definite integral is that once you do the integral, the definite integrals, you need to put the endpoints, right? And also definite integrals, you shouldn't have the plus c. And this is only for indefinite, okay? So you put pi and 0 there. When you plug in pi, you get negative 5 cosine pi plus 8 sine pi minus, when you plug in 0, it's minus 5 cosine 0 plus 8 times sine of 0. Okay, and that's going to be, cosine pi is negative 1, so it would be positive 5, and sine pi is 0. This will be 5 times cosine 1, cosine 0, which is 1, and sine of 0 is 0. So that's still 0, and therefore the answer will be 5 plus 5, which is 10. In this next question, when you have a fraction, unfortunately, it's not true that you can integrate these two separately. So you have to split this integral into two fractions first, say 1 over 2 radical x plus 5 cube root of x over 2 radical x. Okay, and then you put radical x as x to the 1/2 power, and this one is 5 times x to the 1/3 power over 2 times x to the 1/2 power. Okay, and then see, the reason is trying to integrate fractions is extremely hard. So the goal is to make this into just a simple power. See, 1/2 can be pulled in front, and 1 over x to the 1/2 power is same as the negative exponent, right? So you want to rewrite this into this form, because this one is x to some power form. That in that case you can integrate by using the power rule. Okay, same thing, 5 over 2, 1/3 minus 1/2, that's negative 1/6 dx. Okay, and then you add 1 to the exponent, which is x to the 1/2, put the reciprocal, which is 2 over 1, okay, plus add 1, which is 5 over 6, and put the reciprocal, which is 6 over 5. Okay, the thing is that these cancel. Oh, by the way, you have to still evaluate 8 and 1, right? So here's what we have. We have 8 1/2 power. 6 divided by 2 is 3, so 3, 8 to the 5/6 power, minus, you plug in 1, 1 to the 1/2 power, plus 3 times 1 to the 5/6 power. That's just 1. So it's going to be, well, I think what you can do here is, I mean, this is not necessary. At this point, you can just use your calculator to find the exact value. But if you really want, you can rewrite this as 8 to the 1/2 power times 1 plus 3 times 8 to the 1/3 power, because 1/3 plus 1/2 is 5/6 minus 4. And another thing that you have to know is that 8 to the 1/3 power is cube root of 8, which is 2, right? So using that, this will be 2 times 3 plus 1, that's 7, and this is square root of 8, so we have 7 times square root of 8 minus 4. So you can simplify in that way. Okay, this is another very similar question. You split into 2. X to the first power divided by x to the 1/2 power. Oh, this one also, we should rewrite that as x to the 1/2 power. And then we use the exponential rules. 1 minus 1/2 is 1/2, so it's negative 3 x to the 1/2 power plus 5 times then x to the negative 1/2 power. Then you use the exponents, so you add 1, which is 3 over 2, put the reciprocal, 2/3. And then this one you add 1, which is 1/2, put the reciprocal, which is 2 over 1. And then you plug in 25 and 1. 3 cancels, so it's negative 2 x to 3 over 2. Half power is square root, so this is like x cubed square root, or x cubed. It's better to put the cube outside, that makes things easier. And then 5 times 2 is 10, and 1/2 power is square root of x. Okay, so let's plug in these numbers. First, when you plug in 25, the square root of 25 becomes 5, so it will be negative 2 times 5 to the 3rd plus 10 times 5, because square root of 25 becomes 5, minus negative 2 times 1 plus 10 times 1. And that's 125 times 2, negative 250 plus 50, that's negative 200. This is negative 8. So the answer is negative 208. This one, you have to know the integral of e to the x is e to the x, and the integral of 2x, antiderivative of 2x is just x squared, right? So that's a rather easy question. When you plug in 0, it's 0 squared minus 9 times e to the 0th minus negative 1 squared minus 9 e to the negative 1. You subtract the 2. Anything to the 0 power is 1, so this just becomes negative 9. This will be 1 minus 9 over e. So you end up with negative 10 plus 9 over e as your answer. Okay, here is something quite different from what we are used to. This has a squared, right? It's very tempting to try to integrate just the thing inside and then square the result, but that's not true. This is not the same thing. This is not the, maybe I should write in red, so it's not the same as integrating 2 radical x minus 3 over radical x dx and then squaring it. Okay, unfortunately, it doesn't work that way. Okay. Rather, what you need to do is to use the fact that a minus b squared is a squared minus 2ab plus b squared, right? So you probably know this identity and apply that to here, which yields 4 to 16, and then you square the first, minus 2 times 2 radical x times 3 over square root of x plus 3 over square root of x squared. Okay, so in this formula I'm letting a to be 2 radical x and b to be 3 over radical x. Okay, And that's going to be 4 to 16 of 4x. X's cancel, and 2 times 2 times 3, that's 12. And this cancels, and you get 9 over x. Okay, another thing that you have to be careful is that integral of 1 over x, despite the fact that you can rewrite this as x to the negative 1, the power rule does not apply here, because if you add 1 and put the reciprocal, you end up with a reciprocal of 0, right? So this actually has the ln of absolute value of x as your antiderivative. So it's very important that you use this to integrate that. So 4x integrates to 2x squared, 12 integrates to 12x, and these you can quickly check. 2x squared, if you differentiate, you get 4x, so of course this is the antiderivative. If you differentiate 12x, you get 12, so that's the antiderivative. And then you have 9 times 1 over x integral is ln of absolute value of x, and then you plug in 16 and 4. And that's going to be a huge number. So after this, you will need to use the calculator, but let's see, 16 squared is 256 times 2, that will be 512. 16 times 12 will be, I think, 132. Let's see. 16. Okay. Oh, wait. 14, 196. Minus, right, 192, sorry. Okay, so that's going to be 192, and then plus 9 ln of 16, minus, when you plug in 4 squared is 16, 16 times 2 is 32, 4 times 12 is 48, plus 9 times ln of 4. So if you simplify, 512 minus 192 is 320. Okay, and then 32 minus 40 is negative 16, but this minus will make it positive 16. And then 9 ln of 16 minus ln of 4. And 320 plus 16 will be 336 plus 9 times ln of 16 over 4, which is 4, right? So you can rewrite that as 4, and that will be your final answer. Okay, for this one you have something that looks like an inside function, and the derivative of this is 2x, and 6x is quite similar to 2x, right? 6x is just a constant multiple of 2x. In that case, you use the u substitution. So let's try the u substitution. U equals to x squared plus 5. And then du is the derivative of this, which is 2x plus 0. And then you multiply by dx. So that's the format. When you do u substitution, you differentiate and then put, say, du as the derivative times dx. Okay, once you do that, then you want to solve for dx so that you have dx equals to 1 over 2x du. And now you're almost there, except we still need to do something more. When x is 2, 2 squared is 4, 4 plus 5 will be 9. When x is 5, 5 squared is 25, 25 plus 5 would be 30. Okay, and then 6x, we decide to call the entire thing inside as u, and then dx is 1 over 2x times du. X and x cancels, and then 6 divided by 2 is 3. Square root of u is u to the 1/2 power. And then this is a power rule, so you add 1 to the exponent, put the reciprocal in front, so these cancel. and therefore you have 2 times 30 goes into u. We work so hard so that these are values of u, right? So you don't have to go back to x. These are values of u, so these go into u. Okay, so you have 30 to the 3/2 power, and minus 2 times 9 to the 3/2 power. Okay, so this is 2 times square root of 30 cubed, and 2 times square root of 9 and then cubed. 30 cubed is 27,000 square root, and then square root of 9 is 3 to the 3rd power is 27, times 2 is 54. So that's going to be your answer. If you want, you can further simplify this by pulling a 3 outside, and 30 can come outside. It'll be 30 times square root of 30. So you can further simplify it by pulling a 30 out. 30 times 2 is 60, and what's left is 30. So that would be another way to write down the answer. Okay, here again, 4 minus 3x looks like something that's inside, so you use the u substitution. So du, you put the derivative of this, which is 0 minus 3 dx, put the negative 3 dx equals to du, and then you solve for dx, which says that dx is negative 1/3 du, and you have everything. Square root of u, dx is negative 1/3 du, and you rewrite square root of u as u to the 1/2 power. Negative 1/3 is a constant multiple, so I can bring it outside. And then negative 1/3, you use the power rule, so 3/2, put the reciprocal. 1 times 2 is 2, 3 times 3 is 9. And finally, you replace u by 4 minus 3x, so negative 2/9, 4 minus 3x, 3/2 power. Let's see. Now in web work, you should probably write this as negative 2 divided by 9 times 4 minus 3x. You use a caret for the power, and you put 3 divided by 2 plus c, just like this, okay? Alright, so your question should be probably different than this one, so try to do similar things and try to write your answer this way. Okay, this last question here, it's again u substitution, and you set u as, see, this thing looks like cosine x squared in the denominator and 6 times sine x, and you want to set u as cosine x because the derivative of cosine x is negative sine x, and you have a sine x there, right? So you want to use u as cosine of x, differentiate both sides, so that du is negative sine x dx, and then you divide by negative sine x to get dx equals to negative 1/sine x du. Okay, so that's what you want to do. Also, you need to know the values of u when x is 0 and x is pi/6. So when x is 0, you get u equals to cosine of 0, which is 1. So u is 1. When x is pi/6, then u is cosine of pi/6, and cosine pi/6 is radical 3/2. So these are the values you need, and we have everything we need to do the integral. So first you go from 1 to radical 3/2. 6 sine x, I don't know what to do, but down here, cosine squared x really means cosine x squared, and because cosine x is now u, I put u squared. And then your dx is now negative 1 over sine x du, and these two signs perfectly cancel each other, leaving you with just negative 6, which you can bring it outside the integral, so it's negative 6, 1 to radical 3 over 2, and then 1 over u squared is the same thing as u to the negative 2 du. Okay. Now if you integrate u to the negative 2, that's u to the negative 1. Reciprocal of that will be, again, negative 1. The reciprocal of negative 1 is negative 1. So you have these, and remember these are values of u, so those values go into u. So these two cancel, not these two minuses cancel, leaving with 6u to the negative 1. And maybe I should really write u to the negative 1 now as u 6 over u. Okay, so these are the values we need. The first one is 6 over radical 3 over 2 minus, when you plug in 1, it's 6 over 1. Okay, this is dividing by radical 3 over 2 is multiplying by 2 over radical 3, so it's 12 over radical 3 minus 6. So that should be a good enough answer. If you rationalize the denominator, however, you can multiply by radical 3, top and bottom, to rationalize the denominator. Radical 3 times radical 3 is 3. And the final answer can be written as 4 radical 3 minus 6, just like